Here are solutions to homework set number 9 for ECE 111, Introduction to ECE. This homework set looks at using Matlab to solve problems that you'll encounter when you take Circuits 1. Specifically, we're going to look at voltage nodes and current loops. Now, in linear algebra, you learn about how to solve n equations and unknowns using matrices. We basically beat that method to death for the next 4 years. If I have a problem and I can reduce it to n equations and unknowns, then I can solve it. For example, given this circuit, suppose I want to know the voltages V0 through V5. I have 6 unknown voltages. If I can write 6 equations for 6 unknowns, I can solve for those voltages. So the approach with voltage nodes is if I have a voltage source, I know what the answer is right away. This voltage source says the voltage difference between V0 and 0 is 10. So there's my first equation, V0 equals 10. For the other equations, currents have to balance. Kirchhoff's current law says the currents from the node have to add to 0. And there's a couple ways you can write that. You can say current in equals current out. Sum of the current from the node equals 0. Current to the node equals 0. My preference is add the currents from the node to 0. And if you do that, there's a pattern. If you switch it around, like current in equals current out, you tend to get sign errors. Let's just do the current from the node. All that current has to add to 0. So if I look at node V1, I've got 3 resistors attached. The current IA plus IB plus IC has to add to 0. The current IA is V1 minus V0 over 10. That's this term. Current down is V1 minus 0 over 200. And current to the right is V1 minus V2 over 15. The pattern is when I write this, all the V1s are positive. Everyone else is negative. In addition, if I check the units, this is volts over ohms is amps plus amps plus amps equals 0. The units have to match up. If I did something like this, forget that 15, I've got amps plus volts. That's nonsense. You can't do that. It's like saying, what is 2 apples plus 3 days? The units don't match. It's a nonsense question. So that's node V1. Node V2. I have the current left, current down, current right equals 0. The current left is V2 minus V1 over 15, this term. Current down is V2 minus 0 over 100. Current right is V2 minus V3 over 20. Repeat for nodes 3, 4, and 5, and you wind up with 6 equations, 6 unknowns. Once you have 6 equations, 6 unknowns, is go back to linear algebra and solve. To do that, I'm going to rewrite these equations, group all the terms. So doing some algebra, well, actually, before I do that, kind of notice on all the terms at node 2, all the V2s are positive, everyone else is negative. Node 3, all the V3s are positive, everyone else is negative. Amps plus amps plus amps, kind of a quick way to check for sign errors. Grouping the terms. Those 6 equations, grouping terms, look like so. To solve, put in matrix form. So what I like doing is, if I write this as V0 through V5, order doesn't actually matter, just have to be consistent. If I go V0 through V5, I'll put reminders. The first column is times V0, this is times V1, times V2, 3, 4, and 5. So the first equation, V0 equals 10, so it's 1 times V0 is 10. Second equation, minus 1/10 V0, this mess times V1, minus 1/15 times V2 equals 0. Third equation, minus 1/15 V1, that mess times V2, minus 1/20 times V3 equals 0, and so on and so on. There is a pattern. The diagonal is positive. The other terms are negative. What this also tells you is that I have 3 resistors attached to node 4, 4 is attached to 3 through 25 ohms, 4 is attached to 5 through 30 ohms. So you can kind of see the circuit through this matrix. If you can't, not to worry. Just a matrix. Once I have this in matrix form, I can throw it in Matlab. This is a fairly large matrix, so what I did is I did the first row, second row, third row, fourth, fifth, sixth. Pack them all together. Here's my A matrix. Call that B. Here's my B matrix. And the voltage is inverse of A times B. Note on the homeworks, a couple students are running into problems. If you make this a row matrix, Matlab will give you an error. A is a 6 by 6 matrix. B has to be 6 by 1. When you multiply matrices, the inner dimension has to match. If I made B a row matrix, that'd be a 6 by 6 times a 1 by 6. Matlab will complain saying, can't do that. And B has to be a column vector. I like printing it out so I can check to make sure. Yep, that's a column vector. I'm doing it right. When you're done, these are the voltages. That's B0, 1, 2, 3, 4, 5. To check my answer, you could use Chegg, which is every faculty member's enemy, or just use CircuitLab. You don't need Chegg. CircuitLab is a really friendly program. Just drag and drop, draw the circuit, label the voltage nodes, do a DC solver, and I get exactly the same answer. So again, you don't really need to use Chegg or ChatGPT or anything like that. Throw the circuit in CircuitLab and check your answer. If your answer doesn't match up with CircuitLab, either CircuitLab is wrong or your calculations are wrong. My money is on your calculations. CircuitLab is pretty well debugged. Okay, so that's one approach. A second approach is called current loops. With current loops, I count the number of windows. I have 5 windows. I have 5 unknown currents. Label those currents. I like doing clockwise rotation around each window. Call this one I1, I2, I3, I4, I5. You can do it other ways. For now, I would just do separate loop in every window, each going clockwise. If you do that, there's a pattern. Once I define the current loops, I need to come up with 5 equations for 5 unknowns. Those equations are Kirchhoff's voltage law. If I go around a loop and wind up where I started, these voltages have to add to 0. So let's do that. As I go around the loop, if I hit the minus sign first, I'll subtract. Plus sign first, I'll add. So start from here. As I go up, this is minus 10 volts. As I go right, the voltage through that resistor is I times R. That's 10 times the current going right, 10I1. Go down here, that's 200 times the current going down. The current going down is I1 minus I2, this term. And I'm back where I started. That equals 0. Around loop I2, I go up. That's 200 times the current going up, 200 times I2 minus I1, plus 15 times the current going right, 15 times I2, plus 100 times the current going down, 100 times I2 minus I3. Likewise for loop 3, 4, and 5, I get my 5 equations, 5 unknowns. If you draw the currents all going clockwise around each window, there's a pattern. Around loop I1, all the I1s are positive, everyone else is negative. Around loop I2, all the I2s are positive, everyone else is negative, and so on. In addition, the units have to match. I have volts plus I times R, volts plus volts equals 0, volts plus volts plus volts equals 0. If you ever do something like this, I have volts plus amps. You know, right away there's a mistake. You can't add volts and amps. The units all have to match up. Once you get 5 equations, 5 unknowns, solve. To do that, group the terms, bring the constants to the right, put this in matrix form. In the way I like writing it, if I put the currents in this way, then the first column is times I1, I2, I3, I4, I5. The first equation is 210 I1 minus 200 I2 is 10. Second equation, minus 200 I1 plus 315 I2 minus 100 I3 is 0, and so on. Again, what you see is kind of a pattern. The diagonal is positive. The other terms are negative. To solve, I throw that into Matlab. Again, print it out just to make sure Diagonal is positive, other terms are negative, no sign errors. This is my B matrix. Here's my A matrix. The current is inverse of B times A. And again, the dimensions have to match. This is a 5 by 5 matrix. That's B. A is a 5 by 1 matrix. Got to be a column matrix. Row matrix ain't going to work. Multiply together, you get the current. That's in amps, or just to be consistent with Circuit Lab, times 1,000. This is in milliamps. To check your answer, throw it in Circuit Lab. In Circuit Lab, if I click on the left side of the resistor, that'll tell me the current going in here. That's I1. Click on the left side of the resistor, that'll tell me the current, I2. And I get exactly the same answer that I got with Matlab. Like the last one, 15.13 milliamps, 15.1296 milliamps, same thing. So that's one of the techniques we'll be using in Circuits 1 to solve for circuits. The whole trick that you're going to be beating to death for the next 4 years is n equations, n unknowns. Anytime I have a problem, if I can express it as n equations, n unknowns, I can solve. And that's why you took linear algebra. That's kind of fundamental course. We use that technique over and over again. And that is homework set number 9 for ECE 111.